Hello everyone. Today I'm going to talk about how do we set up the movement simulation for the chess robot we have created. So the main motivation is to use existing library called Moveit in order to control our UR5e robot. Why we need to do this is because if we want to move the robot to a point anywhere in the space, we can use this library Moveit to do the path planning for us. We do not have to worry about the inverse kinematics and solving them and then moving each control, each joint. Everything would be taken care by the Moveit framework itself. It's a very convenient tool when we want to do uh, certain pick and place tasks or anything with related to moving a robot. We go towards Moveit to do that. So the necessary library is Moveit, which comes pre-built when you are downloading RAW. So you don't have to worry about downloading it. Uh, and once you uh, want to set up a Moveit for your uh, function, you can just launch the Moveit by saying ROS launch Moveit setup assistant dot launch. Once you launch it, you would get this Moveit setup assistant wizard, um, which helps you to go through each and every stage of setting up your Moveit configuration files. And here it will go through like how, setting up the collisions, setting up the planning groups, and so on and so forth. This has been extensively explained in many other videos, and I'm going to attach a link to at the bottom of this video in the video description so that you can use this link to kind of do the setup. It's the same thing which I have done, and you can follow through this in order to get through the smooth setup system. And at the end, you would have the complete configuration file saved in this UR5e Moveit config. Um, so, but the problem with Moveit is that this self-generated file will not work very well for when you're trying to do Gazebo simulation. Uh, so you can see here, this is the UR5e configuration file, which has like a config and no launch files. Uh, If you see the ROS controller.yaml configuration file, this one is the one which we need to change for our robot to work in Gazebo, and I'll tell you why. So we have to first comment this out and then include this set of uh, commands in our configuration file. This is because first we need to have a joint state controller running. And then the next one is that the namespace of all these controllers has to be effort joint trajectory controller, because that is ta- namespace all uh, the Gazebo would be publishing on, and only linking that would enable us to control the joints in Gazebo environment. So we need to do that, include all the joints, which you can see here. Once we have done this, now we should be able to control it on Gazebo. But in order to launch the simulation along with the Moveit, we need to add some files in our launch file, which we had created earlier. So first we need to add planning context.launch, which was generated in this whole setup assistant. And similarly, we need to launch the move group and then move it harvest. So these are the three files which you need to include in your existing launch file, so that you can, when you launch this file, you are able to launch the Gazebo world and an harvest on the side so that you could control your robot. Um, so moving on, this exactly is the problem if you don't do these changes. What you would see is that the manipulator controller follow joint trajectory is like action client cannot be found. So this is the error which we have solved in that previous slide, and by doing so, we will not encounter this error. And we would be able to get something like this. Once we launch that file, we would be able to have the RVIS setup and the Gazebo, which both are related to each other, as in when we move it in the RVIS, which is the robot visualization, we can then plan the trajectory and then send the inputs to the UR5e robot on the Gazebo world, as you can see. So this is basically three things happening. One, the ROS, the second one is the Moveit framework, and then the third one is the Gazebo. So what we have done is we have set up pipelines for the communication between all three individual parts. Um, so by doing this, we would now be able to control the robot, move it, and then uh, do the pick and place in our case. So my next step from here would be to control the grippers, which I was not able to do using this. So what I would be doing is to activate the controllers for the gripper, so I could control it using Moveit. And the second thing, what Moveit provides is an interface. So we can write C++ code, C++ or Python code to command it to the locations we want to move it to. So that would be another thing which I would be doing is to write a predefined set of positions so that the robot is able to move, pick, and place a particular coin in the chessboard. Thank you for listening.